All right, guys, welcome to Chapter 11. Chapter 11, we're going to talk about something that's pretty simple called the Fundamental Counting Principles. And all this is the number of ways a certain number of items M can be chosen from a second group of items N. Okay, and all we're doing here, whatever our choices are, we're just going to multiply them and get our answer. So this is just a lot of multiplication, so fairly easy, right? And then we also have a series of ways so we can look at the ways things can be mixed up. All right, I'm going to do quite a few examples. It's easier to show than it is to try to really just sit and explain it further than that. So I'm going to look at example 1. Okay, and this is on your book page 115. All right. And it says the restaurant offers 10 appetizers and 15 main courses. So we have 10 appetizers, okay, and 15, I'm going to call them MC main courses. How many ways could you order a 2-course meal? And when they're saying a 2-course meal, they mean one item from here and one item from here. All right. So now what we're going to do is just multiply those. So we have 10 multiplied by 15, and that is going to give us 150. Okay, so we have 150 different ways we could go ahead and order an appetizer and a main course. Okay, we're also going to look at example 3 on the same page, and I'm going to be ordering pizza. This is one of my favorite things ever. A pizza can be ordered with 2 choices of size, so you can have a medium or a large. 3 choices of crust, okay, thick, thin, or regular, and 5 toppings, choice of 5 toppings, okay? And it's ground beef, sausage, pepperoni, bacon, or mushrooms, okay? How many different 1-topping pizzas can be ordered? So just 1 topping. Okay, I want more than 1, but that's okay. So for the first one, we have 2 choices. We have a medium or a large. Those are only choices we have. We have 3 crust sizes, so I could choose one of those 3 crusts, and 1 of the 5 toppings. Okay, and all we're going to do is multiply those 3 things together and end up with 30. So there's 30 different ways I can order a 1-topping pizza. Okay, pretty easy right there. I'm going to look at example 5. It says checkpoint 4 on the next page. Okay, and this one is a little bit long, but it's pretty good. So car manufacturers are now experimenting with lightweight 3-wheeled cars. Okay, that's just some information that they have out there. They're designed for one person and ideal for city driving. Suppose that you could order such a car with a choice of 10 colors, with or without air conditioning. In Florida, we aren't going without air conditioning. Electric or gas powered, and with or without an onboard computer. Okay. This car is also available with or without a GPS. Okay. How many ways can this car be ordered in terms of these options? Okay. So first we're going to look at the fact I can order this car in 10 colors. Okay. So 10, my first number. Now, every other one of these I have 2 choices, with or without. So each of these has 2 choices I can choose from. I either want it or I don't. Choice is mine. Okay? So each of these I have 2 choices. And I just multiply those things together. And I can order this new car with 3 wheels 160 different ways. Okay. I'm going to look at example 7 next. Okay. And you are taking a multiple choice test that has 6 questions. Okay. And each of the questions has 3 answer choices. Okay. With only 1 correct answer per question. That's important. And if you selected one of these 3 choices for each question and leave nothing blank, so you've tried all 6 questions, how many ways can you answer the questions? Okay. Each question here has 3 choices. So every single question has 3 answers. And the way we're going to handle this is each question has 3 choices. Right? And because they're successive and each one has the exact same choices, right? One A, B, or C, take that to a power of 6. So instead of multiplying these 3's by themselves 6 times for each of the 6 questions, we're just going to go ahead and use it as a power. Okay, so 3 to the 6th power. Each of these 6 questions has 3 answers, or I could sit and multiply it 3 times 3 times 3 times 3 times 3, and I get one more, okay? And that's kind of tedious. So if I know each of these 6 questions has 6 questions has 3 choices, I can go ahead and write it like this and get 729, and you'll get the same if you multiply it all out. Okay. Now I'm going to go ahead and look at example 11. This will be my last one. Okay. And license plates in a particular state display 2 letters followed by 3 numbers. Okay. And to give an example of something like AT 887. Okay. Something like that. All right. How many different license plates can be manufactured for this particular state? Okay. So here we can have 2 letters, okay, and 3 numbers. Right? So we got to look at how many different letters there are for the first one. Well, I have 26 choices for that first letter. Okay, there's nothing saying that they can't have the same letter, okay? So for the second letter, I also still have 26 choices. 26 letters in the alphabet. Now for numbers, I need 3 numbers. Okay. In order to get those numbers must be between 0 and 9. Okay. 0 counts as a number, so this gives me a total of 10 choices. Okay. So each of these, I can pick any of the numbers between 0 and 9. No restrictions. Okay. And when I go ahead and multiply that together, I get 676,000 different license plates I can create using this format, which is pretty large. Okay, so again, this is the last example I'm going to do for this section. It's just a bunch of multiplication. All right, so please go ahead and work the other ones out. Please feel free to contact me if you have any questions, and I'll see you for the next section.